Hey guys, I have here the Sonoff Basic Wi-Fi Smart Switch. And what this is it's a little device that connects to your Wi-Fi network and allows you to control a load that's plugged into it through either your phone, or it also pairs with several smart speakers such as the Amazon Alexa or Google Assistant. I'm going to be using this to control a secondary load based on the state of charge of my battery bank. Before we get started, what we're going to do is flash this with some custom firmware called Tasmota, and that's just an open source hobbyist firmware that will allow us to control the device directly using HTTP or things like MQTT. If you use it out of the box with the stock firmware, you have to connect it to the internet and the cloud and do all that kind of stuff. This will allow it to exist solely on our local private network. So in the box you'll get screws. So this is a Sonoff, and you'll see it's rated for 90 to 250 volts, 50 or 60 hertz, and you can do up to 10 amps, and that 10 amps is a resistive load. So these two sides come off. So in order to get this flash, we'll take it out of the case. And here you can see the actual board. It's pretty much just a relay and then some components to convert the AC voltage down to DC for the board to use. And then there's an output over here. This is the Wi-Fi antenna. So in order to flash this, I'll be using this USB to serial adapter. I bought this on Amazon. I went for this specific model because this model has a switch that allows you to control between 5 volts and 3.3 volts, because the Sonoff Basic requires 3.3 volts. If you try to put 5 volts through it, you'll probably blow it up or something. But I should say that the Sonoff did not come with this 4-pin header here, which will be connecting the USB to serial interface to. So I just had to solder that 4-pin header in. It only takes a minute to do. So the USB to serial adapter does come with this cable. So you'll see the 4 pins we're going to use are the VCC, the ground, the TX, and the RX. So the VCC will get connected to the 3.3 volt pin on the board, and obviously the ground to the ground. And the pin out for these 4 pins is actually on the bottom. So you can see there's ground, TX, RX, and then 3.3 volt. And also when you connect the TX and the RX pin from the USB to serial interface, you'll want to swap the pins on the board. So the RX from the interface should go to the TX on the board, and the TX from the interface should go to the RX on the board. So double check your connections, and then double check that this switch is set on 3.3 volts. In order to load the firmware, we'll have to put this device in flashing mode. To do that, you just push and hold on the button while you plug in the USB plug. Then you can release the button. And the first time you plug it in, it will install some drivers in your computer. So we'll switch over to the laptop and show you how to load the firmware. So before we begin, you'll need to get a few pieces of software. The first piece of software we'll need is ESP-Easy, obtainable from GitHub. And I just downloaded the ESP-Easy Mega, the most recent release. The second piece of software you'll need is the Tasmota Firmware itself, also obtainable from GitHub. And you'll scroll halfway down the page. You'll see several bin files. The one you'll most likely want is just named sonoff.bin. If you prefer a language other than English, there are different versions of the sonoff.bin, such as GR is German, FR is French, etc. I'm also using a program called Termite. It's a very basic RS-232 interface for your COM port, and I just downloaded the program-only version. So once you have those softwares downloaded, just extract them all to the same folder. And we'll begin by opening the Flash ESP8266 file. So first you'll select your COM port. I only have one COM port. If you're not sure which COM port corresponds with your USB to serial device, you can click Start and go to Device Manager and just expand the section that says Ports, COM, and LPT. And you can see here the USB serial port interface is COM11. And then you'll select your firmware file. By default, it's going to load the list of bin files from the same directory as the Flash executable. So you'll want to make sure, like I said, that your files are extracted all to the same folder. Once you have those two selected, click Flash. As it's flashing, you should see the TX and RX lights blinking on your USB to serial interface. That way you know it's actually doing something. And flash complete, click OK, and then close the ESP Flasher utility. Now the next thing we need to do is pair it with our Wi-Fi access point. And once the flash is complete, you'll want to unplug the serial interface and then plug it back in. And then we'll open the Termite software. The first thing you'll do in Termite is click on Settings and verify you have the correct COM port set. This is the same COM port from before. And your baud rate should be set to 115/200, then click OK. And then once it's connected, the first command we'll issue is SSID1, followed by the name of your access point. And the second command is password, followed by the password for your access point. And you'll see it connected. So the IP address it assigned from DHCP is listed here, 192.168.0.214. And if you open up your web browser and type that in, you'll see the Sonoff interface. Now one more thing to do is through the configuration on this menu for the Wi-Fi, you can't set a static IP address, and we need to make sure the IP address doesn't, because that IP address will be used in our code. So you can either do that through your router, you can set up a static DHCP entry, or you can just set it in Tasmota itself, again using the termite console. So we'll type IP address, we'll type IP address 1, followed by the IP address you want to assign. So we'll just give it 240 to test it out. IP address 2, the gateway address or your router, and then IP address 3, and the net mask. And once that's done, we'll want to restart it either by unplugging the USB interface or typing restart 1. Okay, and you'll see it's restarting. And it has a new IP address of 240, so we should be able to open up the command prompt and ping that IP address. And there we go, we're good to go. So you can close termite, you won't need that anymore, and you won't need the software anymore. So the toggle button will toggle it on and off. Configuration, you can set up the timer, Wi-Fi, we already saw the Wi-Fi, MQTT, logging, there's a whole bunch of other things you can set up in here. So what we'll do is connect a small load to it and just verify it's working. You can disconnect the USB to serial interface and remove the pins at this time. For testing, I just have a regular extension cord which I cut, and one side goes into the input and the output goes to the other end of the extension cord with the lamp plugged in. Now it's important to remember when you're wiring this that this is mains voltage, either 120 or 240 depending on what country you're in, and any of those voltages can severely shock you if you don't know what you're doing and you mess something up. You need to be extremely careful while doing this. One other thing to keep in mind is you need to make sure you have the neutral on the line wired to the correct contacts coming in and the correct contacts going out. You can't have them crossed. Anyway, once you plug it in, you'll see the LED starts blinking. So once you pull up the Tasmota computer interface, you should be able to click the toggle button and see your light turn on and off. Hopefully that will help you get started if you're looking to do something similar. I'm not going to say what I'm going to do with this exactly yet, but it is a really cool project. Stay tuned for the next video coming up, which will explain more in detail about how this is going to work. I will include links to where I bought these products, along with where to download the software in the description below if you're interested. Any questions, comments, or suggestions, leave them below like usual. And don't forget to like and subscribe. Thanks for watching.